2D materials, the super thin heroes of science. In the world of science, sometimes discoveries happen that make the first question in your mind this: does this really work, or did scientists put a little too much sugar in their coffee? And 2D materials are exactly this kind of discovery. These materials, whose thickness is almost as thin as a single atom, have started a kind of revolution in the technology world. One of the most famous examples, graphene, is so thin that it is almost invisible, but at the same time stronger than steel. So imagine, your phone screen could be as thin as paper, and at the same time strong enough that even the Hulk could not break it. Yes, science sometimes progresses like a Marvel movie. What are 2D materials? 2D materials are special materials whose thickness is only a few atomic layers. Normal materials are three-dimensional, but these materials behave almost completely in two dimensions. Because of this, their electrical, optical, and mechanical properties are quite different from classical materials. For example, graphene conducts electricity so fast that some scientists describe it as a highway for electrons. In other words, if an ordinary cable is a village road, graphene is literally like the unlimited speed Autobahn in Germany. Graphene, the superstar of the 2D world. Graphene is formed when carbon atoms create a hexagonal honeycomb structure. Thanks to this structure, a material that is both incredibly strong and very flexible appears. Another interesting feature is that it is almost completely transparent. So, theoretically, in the future, our phones could be foldable, ultra-thin, and much more durable. It could even be so thin that you might accidentally think the phone in your pocket is a notepaper and write a shopping list on it. Milk, bread, eggs. And by the way, this phone is $2,000. Usage areas of 2D materials. 2D materials are not just toys that scientists play with in laboratories. These materials have the potential to be used in electronics, energy storage, sensors, and even medicine. For example, graphene batteries could charge much faster than today's batteries. So in the future, when you plug your phone in and say, "Let me drink a coffee," your phone might reach 100% before the coffee arrives. Of course, if the coffee machine is made of graphene too, maybe the coffee will come at the speed of light. Scientists should think about that as well. Conclusion. 2D materials are one of the most exciting fields of modern science. These atom-thick materials have the potential to create a revolution in many areas, from electronic devices to energy technologies. Maybe today graphene is only studied in laboratories, but tomorrow it could be in our pockets, our homes, and even our clothes. So don't be surprised if your t-shirt charges your phone in the future. Science sometimes really works thin, atom thin.